So in this video we're going to work through another related rates problem. In this case you might recognize that this is the start of problem 28 from the book. But we have a boat is pulled into a dock by a winch that is 12 feet above the water. The winch pulls the boat at a rate of 4 feet per second, and we want to determine the speed of the boat when there is 13 feet of rope out. So I've drawn a little diagram here, and it's very nice, it's well done. And basically what we want to do is we have this nice dock here. Clearly that's a dock, you can tell it's a dock. It's nice and brown, just like a dock should be. And we've got a winch up here, this little wheel, and what it's going to do is it's going to spin. It's going to pull this rope in, so the rope is going to come in here, and that's going to make the boat pull closer into the dock there. And this is what we want to figure out. We want to figure out how fast is it moving. And the first thing we want to do is we want to start to identify some information. So if you haven't watched the other related rates video, you want to watch that one first. Here is just going to be the brief keywords and things we need to identify. So the first thing we want to do is we want to take this picture here, and we probably want to draw it a bit nicer so we can actually do something with it. So what I'm going to do is I'm going to go ahead and recreate my picture here, and we can see this is just a nice right triangle. And next I want to assign some variable names. So I'm going to call the bottom one boat. That's the distance the boat is from the dock, and I'm going to call it B. Along the hypotenuse of the triangle, I'm going to call that rope, so I'm going to give it the letter R because that's the length of the rope. And last, I'm going to use the letter H to denote the height of the dock that we've been given. And what we also want to do is identify other good information we've been given so far. So let's see, if we look through our problem, we've got that it's 12 feet above the water, and the winch pulls the boat at a rate of 4 feet per second. So this is telling us how fast the rope is changing. So what that means is dr dt is going to be 4 feet per second. But a key thing to note here is that since the rope is coming up this way, the rope is getting shorter. We're shrinking this distance. So my change is actually needs to make sure I make that a negative rate. Another thing we know is that h is always going to be 12. That is, as we pull the boat in here, as this distance decreases, sure, the rope's going to shrink. The distance between the boat and the dock, that's all going to shrink up. But the height of the dock is always going to stay the same. This winch isn't going to go up and down or move or anything. This will always be a height of 12 feet. And last, we want to find out dB dt, because this is the rate the boat is moving at. So this is the rate of the boat. So these are all the things we want to identify to start our problem. The next step in the process is to come up with an equation. So what we have to do is we have to stare at this thing, and we have to think, where is there an equation floating around? And usually a good thing is to look at our diagram here and kind of think, well, what do we know? What have we seen with triangles before? This could be some trig stuff. We look inside quickly and realize we don't really know much about these angles. The only angle we know is 90 degrees. We don't really care about these other angles, so we're going to avoid sine, cosine, all that stuff. We're not going to use those. Instead, we look and we see that since we have the sides of the triangle, we need to use Pythagorean theorem. So what we're going to do is we're going to use the equation h squared plus b squared is equal to r squared. Well, now it's time to take a derivative. So always remember this is calculus, so if you don't take a derivative or an integral, you've done something wrong. So we want to look at our equation we had. H squared plus b squared is equal to r squared. And we're going to differentiate implicitly. So the key thing to every related rates problem is to remember that everything is really secretly a function of t. We could have written this as h of t squared plus b of t squared is equal to r of t squared. You can kind of see it's small, it's okay. And so when we take the derivatives of this, what we're going to get is we're going to get 2 times h dh dt via the chain rule plus 2b times dB dt via the chain rule is equal to 2r dr dt via the chain rule. So the last step here is to solve. And recall way back in step 1 we said that this is what we want to figure out. We want to figure out dB dt. And recall all the things that we learned back in step 1. So we said we knew a lot of stuff. We knew that h was going to be 12. We were currently 12 feet high. It's not changing, so the rate of change in the height is 0. We had 13 feet of rope out. we were pulling in the rope at -4 feet per second, or we're pulling in at 4 feet per second. The only thing is we still don't know what B is, but what we're doing is we're able to figure out what B is. We had the Pythagorean theorem before, and we had the equation h squared plus b squared equals r squared. So we know that 12 squared plus b squared is equal to 13 squared. And doing a little bit of solving, this tells us that b, of course, has to be 5. So putting all these pieces into the equation, we have 2 times 12 times 0 plus 2 times 5 times dB dt, which we want to solve for, is equal to 2 times 13 times -4. So we do the arithmetic, we solve for dB dt, and we get negative 10.4 feet per second. So this is how fast the speed of the boat is moving, negative 10.4 feet per second. So the next part of the problem asks you to do a little more with this. It's going to be a slightly different setup, but hopefully you can figure it out. As always, if you have any questions, please let me know. Thanks.